So SoftRAID has been around for over 20 years. It was first developed, actually the first SoftRAID engineers developed the first version of AppleRAID for macOS 8. And then SoftRAID was developed afterwards. I actually have been working on it for 19 of the 20 years that it's been in existence. So when I first started, I was really excited about making a drive go really fast, making a volume really fast. I would get incredibly excited if I could just take a little bit off the speed of doing something. And then in 2003, I joined a volunteer fire department, and all of a sudden I would start seeing people in the absolute worst time in their life. It would be a time when their house had burned down, their computer looked like a beer can that had been left in a campfire, and they had lost absolutely everything. And it changed the way I looked at software and the way I looked at people's storage of their volumes. Instead of looking at making things really fast, I started looking at how could I make them really reliable. So reliability became my prime focus, and speed sort of took a second seat. Now, it's not like I totally gave up on speed. If you come to the OWC booth, you'll see that we already have this great Viper product that's in certification. It's going to be shipping this summer. It's allowing us to do 4 gigabytes a second write and 4.6 gigabytes a second read speed. This is unheard of, and it's also impossible to get with a hardware RAID device. We get that by actually connecting 2 Vipers to 2 separate Thunderbolt controllers, and then getting a combined speed of both controllers to give us more than a single bus can do. So keep in mind, Thunderbolt 3 can only do 2.6 to 2.8 gigabytes a second. We're doing 4.6, and we're able to do that by using the 2 controllers. So SoftRAID protects your data in 3 ways. It protects your data before you start using a disk drive. It protects your data while you're using a disk drive and everything seems like it's going right. And it protects your data after the drive fails. So let's take this one at a time. SoftRAID protects your data before you start using your disks. That sort of sounds a little weird, doesn't it? How can we do that? Well, it turns out that disk drives have a really weird failure rate. There's a huge amount of early failure when you first start using the drive. It's called sort of a bathtub curve. Then the failure rate goes way down, and then after a year or 2, it starts climbing back up. Can you imagine buying a new car and having it fail right off the lot and having maybe 5% of the cars fail? Would you actually buy from that company? Well, the disk drive manufacturers have made it so that people think this is normal. I don't think it's normal. I think what's actually going on is that they don't have the time to test every single sector in a drive. It's cheaper for them to ship you the drive and have you put it on your desktop and start using it. And then if you're one of those 3% have it or 5% have an early failure, you'll ship it back to them and they'll ship you a refurb. That saves them a ton of money. They don't have to have every single drive sitting in their warehouse or in their manufacturing plant for 3 days running and testing before they ship it out. They just do a light test and send it off. So we think what's happening with this bathtub curve is actually that there's a failure from the very beginning of the drive. So when you first get the drive, there's a failure, you just don't see it. So if you imagine that you have a drive which has an error that's 3/4 of the way through, and it's just there, you're not going to see that until you start using it. So you'll start using the drive, and when you first get it, it's all empty. You start using it a month later, you've got data that fills 1/4 of it. 2 months or 3 months later, you're like half full. And then 6 months later, you finally hit that space where you filled it up enough and you've hit the bad section of the drive. Now, to you, it just seems like it failed after you've been using it 6 months, right? But actually, that failure was always there. You just never hit it. So what we suggest you do is what we call disk certify. And by disk certify, in SoftRAID, that is basically the process of writing data out, a random pattern out to every sector of the drive and reading it back. And we do this 3 times. And then if the drive fails certification, what you can do is you can send it back to the place you bought it and get a brand new drive. If you did it 6 months later, you're going to get a refurb. We don't want you to do that. We want you to get a brand new drive when it fails. Let's do a demo of SoftRAID, and I'll show you this in action. So here I have a drive that's in a Thunderbay enclosure, and I just click on the drive. Let's go to this. Click on the drive, and I say certify. and we get the certification window. Now, the default is that we do 3 passes, writing a pattern of random data, reading it back and making sure it's right, writing a second pattern. The third write is always zeros, and the reason for that is my friends at DriveSavers say if you write zeros, it's so much easier, God forbid, if you need to send the drive to them, it's so much easier for them to get the data off of it. So we write zeros at the last pass. So these are 3 terabyte drives. And when I start the certify, you'll see that SoftRAID says it's going to take 25 hours, just over a day to do a 3 terabyte drive. A 6 terabyte drive is going to take roughly twice as long. It's going to take 2 days. So you asked me, why should I spend 2 days? I got this brand new enclosure, I just bought it, I'm super excited about using it, but I can't use it. You're going to make me wait 2 days before I can use it? My answer to that is twofold. First of all, you can do all your drives at once. You can do, if one 6 terabyte drive takes 2 days, then 4 6 terabyte drives is still going to take 2 days. Set it up on Friday afternoon, it'll be done by the time you come in on Monday, and instead of having a problem 6 months from now when you finally get to the point where you found that bad sector in that drive, you'll know right now that it doesn't work. You'll be able to take, get a replacement, and you don't have to worry about that thing that's happening 6 months down the road. You know that it's going to work. Okay, so it's that 2 days investment is really worth it. If you buy a RAID 5 edition Thunder Bay with drives in it from OWC, we actually do this for you. We actually certify the drives before you ship them, so it's our 2 days, not yours, that makes the difference. So if we now look at our disk drive failure rate, it's gone from this, where we've got a large amount of early initial failure. If we do a certification, we get rid of all that early failure, and we now have just a simple ramp. It looks much better. So we go to this, which is a much more acceptable failure rate. It's very low in the beginning and then ramps up. So just as an aside, what drives do you think fail in droves? It turns out that when a drive first starts production for the first 6 months, we often get customers who order 8 drives and have 6 of them fail. They always blame us. They always say there's a bug in SoftRAID. We say no, there's only been 1 bug in the 7 years we've been shipping this code. That was with 4K drives, and we just fixed it. So unless you've got 4K drives, if there's a problem, it's definitely going to be your drive that has failed. So the 2 types of drives we see large numbers of failures in are drives that have been shipping less than 6 months and refurb drives. If you get a batch of refurb drives, say you've got a really cheap source of drives and they're all refurbs, there's a really good chance that half of them are going to fail certify. If you're buying the latest 10 or 12 terabyte drive and it's just recently in production, there's a really good chance it's going to fail certify. So let's talk about failures while you're using a drive. So you've already certified it, you've been using it. Wouldn't it be great if instead of having this notice that, hey, the drive just failed, if you got some advanced notice about it? Well, it turns out 15 years ago, the drive manufacturers came up with this technology called SMART. The idea behind it was the drive manufacturers, since there's a little computer in every single drive, they were going to use that computer to do a self-test when the drive powered on or when the computer asked it to do, when it set a SMART test request. And the disk drive would then go and test like its read head and its memory and its processor and all these other things, and just make sure that everything was right. Well, it turns out that the SMART test, as you can imagine, if it failed SMART, then the drive manufacturer would have to take it back, right? They'd have to warranty replace it. Well, they don't really want to do that, so they didn't make the SMART test very smart. So we find that it's actually pretty useless for testing whether a drive is good or not. A drive has to really be just barely functioning before it fails SMART. But what came out of this SMART also is there's a whole bunch of things called SMART attributes, and what SMART attributes are is data the computer can ask the drive for. Things like, how many times have I spun up? How many hours have I been used? What's my temperature? How many reallocated sectors do I have? How many errors have I had since I first created? And this information turns out to be a gold mine. So I'm a biochemist by training, and I spent a lot of time reading papers. And in 2007, I ran across this great paper by Google where they took 100,000 disk drives. 2 Google engineers took 100,000 disk drives in the Google pool at the time, and this is in 2007, and they collected all the SMART data every 24 hours. Every 24 hours, that data would just get piped back to their central server, and they would just keep collecting it, and then they'd be watching for drives that failed. And when they found a drive that failed, they would march backward in time and see what smart parameter changed, like a month or 3 weeks or 4 months, 4 weeks before the drive failed. And they found that there were 3 parameters that were highly predictive of drive failure. If any one of these 3 parameters went from 0 to 1, i.e. there was one event or more than one event, the drive was 20 to 60 times more likely to fail. This was really useful. I looked at this study in 2007 and I said, oh my God, this is so fabulous. I can add this to SoftRAID and have a feature where we predict disk failure. And so that's what happened. It turns out that Backblaze discovered or confirmed the finding much later in 2014 and 15 and 16. They continue every quarter. Backblaze publishes a list of drives, a list of smart statistics and drive failure rates, and they use the same sort of thing internally for their internal drive pools to predict when a drive is going to fail. So what Backblaze found was that when you start having more than one failure, so one like uncorrectable error in this case shows that your drive has a 35% chance of failing in 1 year. If you go up to something like 20 uncorrectable errors, the drive has a 100% chance of failing in 1 year, as on average. So these drives are as soon as they trip one of these things, they're on their way out. They're still working though. So you get a little advance notice that SoftRAID will say, hey, this drive is going to fail. You should fix it. You should swap it out. But you don't have to do it right now. You can wait until a weekend or an evening, or say you're in the middle of getting a project done. You get the project done, order your replacement drive, certify it, and then spend an evening rebuilding your RAID and putting it in. It can save you a whole mess of headache because your drive doesn't fail right at the wrong time. So this is what SoftRAID's user interface looks like when a drive's predicted to fail. You'll notice that this drive has, not only does it have 20,000 reallocated sectors, but it has 300 unreliable sectors. And unreliable sectors are just sectors that the drive thinks it's going to have to reallocate. It can't quite read them right, but it can get the data, but it can't quite read them right. So it flags them as, hey, I've got to watch this. This could be a problem later. I might have to reallocate it later. It turns out from the Google study that even an unreliable sector is an indicator that the drive is going to fail. So if we look at our disk failure graph again, what we see is that 3/4 of the drives that end up failing are first predicted to fail by SoftRAID. That means that you can catch 3/4 of the drives that are going to fail before they actually fail and do something about it. The last quarter, we haven't yet figured out a way to predict they're going to fail. We're working on it, we have some ideas, but we don't have a surefire way of figuring those out yet. So if we look at drives that are actually going to affect your workflow because they fail unpredictably, we have a much lower graph. So let's talk about what happens with how SoftRAID protects you after a drive fails. Well, SoftRAID implements RAID levels that offer both redundancy and protection using parity. So the redundant RAID levels are RAID 1, which is mirrors, where all your data is duplicated on more than one drive. If one drive fails, there's always another one with exactly the same data to take over. Or RAID 1+0, which is stripes, meaning data spread across units, and each unit is 2 drives. So if any one drive in any one of those pairs fails, the other one just takes over. It's actually a really robust and reliable RAID level. It's not quite as fast as RAID 5. It's not quite as efficient at using disk space, but we love RAID 1+0. Then the parity or the mathematical protection for data comes with RAID 4 and RAID 5. And what that is one of your disk's worth of space is used to store what's called parity data. And parity is just the sum of the data that's on the other disks. So let's, for example, take a Thunder Bay 4. You have 4 drives in there. So if you're going to use RAID 5, one disk's worth of space is going to be used for parity data. And for every block, that parity is just going to equal the sum of the other 3 drives. Then if you remove, if we think of the last drive being D, we can just say it's A plus B plus C equals D. Then if we remove one of the drives fails, we can recreate what was on that drive, say it was the first one, just by doing a simple, 3rd grade math of take the parity drive, subtract the other 2, and then what's left is the parity. So it allows us to recover from a disk drive failure, and it gives you the performance, most of the performance of a stripe. It offers really high reliability. We've been shipping this since 2014, and it's really robust. People worry about two things with this though. They say, isn't it true that software RAID is slower than hardware RAID? Well, actually, as I showed you in the beginning, we have a 4 gigabyte per second solution. If we take that same solution and run it as RAID 5, we still are getting 3.3 gigabytes a second. So we have really high performance. Even with using SSDs, on average, we're using 1/2 of one core only when writing, or only when using a degraded volume that's missing a disk. For reading and for all other things, we're using very little CPU bandwidth. So it's really low impact. Why is it we're able to do this so fast? Well, if you think about it, you can have a hardware RAID box with a little tiny cheap RAID processor in it, which probably can only do one thing at a time. Or you could have the Intel processor in your MacBook Pro or Mac Pro, which has 4, 6, 8 cores, and you can do 8 parity calculations at once. In fact, that's exactly what the SoftRAID driver does. The SoftRAID driver, when it wants to compute parity, we don't want to A, make it take a long time, or B, possibly introduce a drop frame or a stutter in your audio. So we spin up all of your cores at once. If you're on an 8-core machine, we spin up all 8 cores at once. We use them for maybe 100, 200 microseconds. That's a fifth of a millisecond, and then we get off of them. We want to use them as much as possible, as far as, you know, the 100% usage for the shortest amount of time, and then we want to let your job take over, and that's exactly what we do.